Does anybody have a question from the homework that they would like to ask that the key did not answer adequately for them? Okay, yeah.
Can you explain the caveman one? Like, from homework, I really don't get that at all.
What about it?
Like, all of it.
The whole thing?
Yeah.
We didn't have that in the key?
You had a little bit in the key, but I don't get, like, where you got your numbers from, like, how come A equals, I think it equaled 1 or something like that, and then how, like, what E equals, I was just really confused on.
Okay. Okay.
It might take a few hours, but
Who figured it out? That's good. Yeah.
What if you did it this way? If you start to do it this way.
Why don't you just go up and count for us in that system and then tell us what you discovered from that counting?
I used what you did. You showed us the other day. So I had like 3 different things. I had base 5 above it. I had base 10 below it. To keep my brain.
The regular old A, B, C, D, and then what we learned last class is if we hit a number higher than 4, we have to change it. And so then it
This one's a number higher than, higher than 4. Before we had higher than 3. It was 4 or more. This one's,
the last one is 3 or more, this one's, 4 or more, yeah.
you know, if we got more than 3, we had to exchange, right? Here, if we get more than 4, we have to exchange.
Correct. And then the next one was A and E. What I found out is that this E just means 5. And so I'll explain more when I get to higher numbers. And then it just keeps going on to AA, which just means 5 plus 1, because this is 1. And if this E is always 5, I just keep adding onto it.
Oh, it's just 5.
And so if I go to a really, really high number, let's say there's BD. Let's see. BD is 14. So let me explain this real quick. BE, this is always going to be a 5. And then I found out every time there's an E, you have to multiply it to figure out what number it really is. So I go back to B, and this is a 2. So if I do 2 times 5, it's 10. And once I figure out the main number, I can figure out what this is. So it's just 10 plus, and then D, since D is 4, it's 14. And if you really want to go into high numbers, I figured out what 50 and 60 were. And then, let's see, E is 50. So what I have to do is this E is 5. And then if I do, let's see, not very changed it. Forgot to write that one down. It's in the notes somewhere, but I can't find it. But that's pretty much what I found. And so, do you want me to do one of the arithmetic problems, or? I don't know. It's all in my head, and I'm having issues trying to figure it out. If it has an E in it, I knew that it meant 5. And every letter after that, you
What
just
is
had to
that
add.
E?
It's a placeholder.
It's a placeholder. That is 5. That is the number 5. That's our number 5. In Xmania, it's AE, but for us, that's 5. So if you held up this many fingers, they would tell you that, well, that's AE. So what does it mean? Who can go a little further? She's caught on to what's going on. Yes?
That means you have one set of 5.
The A you said was 1, and I have one group of 5 because it's in that next place over. And the E is actually 0 ones. So it's holding a place saying there's nothing in the ones, but there is 5 because there's 1 in the 5's place.
Now I remember. Okay. So this is the first set is A, B, C, D, and then if I go to the second set after that, it would be a E, which is 5, and then a B, a C, and then a D, and then I gotta start all the way back up here again. And so it would go B, E, and then...
So what would BE be? Okay.
Well, I carry down the 5, and then because I know that this is 2, I have to do 2 times 5 to get 10. And then that way I know
I agree that B
is
is 2, but you're timesing by 5 not because E is 5, but because B is in the 5 to the first place. Okay, that is the number, that's our number 10. Thank you. This is the number 1, that's the number 2, 3, 4, but what's 5? There's no such number as 5 in their system. So they said one group of 5, and I put it in the 5's place, and 0 groups of 1. Then I have one group of 5 and one group of 1s. Does everybody see how that works? So, what would this be? Let's try. What number would that be? Well, just like our system is based on base 10, this place is, ours is 10 to the 0 power, or 1. This is 5 to the 0, or 1. This is 5 to the first, and this is 5 to the second. Well, what's 5 to the second? 25. And how many of those do I have? 2. So this is really, this number right here is really a 50. 2 25s, right? D is what number? 4, but that's 4 in the 5's place, so that's worth 20. And now I've got C, which is 3 in the 1's place, so this number right here is equal to 73 in base 10. This one here is in base 5, and this one's our base 10 number. Does that make sense? Is that helping? Go back and revisit this. Treat A, B, C, and D as 1, 2, 3, 4. Treat E as the clamshell, the placeholder, the 0. Okay? I have to have it there because it shows there are no values in the 1's place. Okay?
I'm just confused why it's no longer base 5 and it's base 10 once you move it to the 7.
This here is base 5.
But then when you add
The
them all,
equivalent is 73 in base 10. They're the very same number. That's
Just
why I
'cause
can
when
put an
you-
equal sign
Just
between.
because when you move it to like our numbers, it puts it to base 10?
Yes. And that's the number that we understand best, right? So it makes sense to us, yeah.
How come it's not a base 4?
Well, let me ask you this question. How many digits do we have in base 10? Digits. Unique ones. Not 9. 10. How? Because of 0. So we have 1 through 9 and 0. How many digits do they have? 5. What are they? A, B, C, D, and E, the 0. Right? In base 9, there is no such thing as a digit 10 as a single digit, right? We have to make 2 digits. Okay? In base 7, there's no such thing as a 7 as a single digit. In base 7, 7 is written 1, 0. That means there's one group of 7 with 0 ones. See, in base 10, we don't, the digit 10 doesn't exist. In base 7, the only digits you're going to get are 1 through 6 and 0. Does that make sense? Does that answer your question?
Yeah.
Okay. Go back and revisit this with that and see if you can make some sense of it. Good. The patterns. There were patterns all over in that, wasn't there? If you like breaking secret codes, bases are wonderful. They're even fun if you don't like it. But anybody else from the homework? Yes.
I don't really understand like how you add or like multiply like those kind of.
Don't
base
worry
numbers.
about that.
You don't have to worry
For
about
now.
it. Okay. Because I wasn't
Just
sure how to do it without
For
converting
this,
it to base.
for
10.
this unit, all you need to do is be able to take a base 10 number and make it into whatever base I ask you, or take that base number and turn it back to base 10. That's all we need to worry about now. Okay?
Thank you.
So, yes, that's a whole different skill.
Yeah.
And we're not quite ready to do that yet. Okay. Let's go here next. You had a PowerPoint where you looked at the fraction 3/4, yes? I'd like to talk about that. The question was, for each of the following examples, could this be a representation of 3/4? If yes, explain how it could be a representation of 3/4. If not, explain why it could not be. Okay? What about that? Pretty obvious. You get a pie, right? It's been cut into 4 pieces and there's 3 pieces left. You're getting 3/4 of the pie, right? That one's pretty easy. What about this one? This could be 3/4. How could it?
Because since there are 4 circles, there are 3 that are filled in and 1 that's empty, so it still represents that 3/4 of the circles are filled in.
Okay. Could this be another number besides 3/4?
Yes.
What? 1/4. How?
Because 1 out of the 4 circles is not shaded.
Okay, so if we're talking about the white part, it could be 1/4. Are there any other numbers that this could be besides 3/4 or 1/4?
4.
Huh?
Just 4 circles.
4 circles, so it could be 4. If you're saying how many circles are there, could be 4. All right. From here on out, we're going to say the thing we're going to focus on is the green. So could the green be 3/4? Yes. Could the green be 1/4? No, we'd have to be talking about the white ones. We're going to focus on the green. There's something else, another number that could be represented here. What?
0.75.
0.75. How did you get that?
I remember. It's like 3/4 of the
So you're just thinking of an equivalent decimal. I'm just seeing, where's 0.75 in this? You just know that it's the same. That's how you got it? Okay. Didn't really come from the picture, it came from it. Well, if it's 3/4, it might be.
And it's like 3 out of 4.
and there's like 4 quarters to make 100, and then there's 3 quarters to make 75.
Oh, so if those are quarters, we've got 3 of them, and that's 75 cents, 0.75. Okay. All right. What if I told you that this is the number 3? 1, 2, 3. 3 holes is 3, isn't it? The question was, could it be 3/4? And the answer is yes. But it could also be the number 3, even if we're talking about the green part. Did everybody see that? Could this be 3/4?
Yes.
How?
Because 9 green out.
9 green out of
12.
12, and 9/12 is 3/4 when we reduce it, right? Okay. In fact, if I were to take these top 2 and move them down here and move those white ones up there, 3 of our 4 rows would be colored green, right? What other number could the green be?
9. 9.
9. There are 9 holes up there. 9 could be the number represented here, right? How many 4s are there in 3? Yes or no? If I ask you, how many 2s are there in 10, what do? How many 2s are in 10? Why don't you go like this? How else could you do that? How else could you write 10 divided by 2? Right? How else could you do it? 10 over 2. So if I'm asking how many 2s there are in 10, that's the same question as how many 4s are in 3. Right? You with me? Well, how many 4s are there in 3? 3/4 of a 4 is in 3. Can you wrap your mind around that? How many 4s are in there? 3/4 of a 4 are there. Right? $18 crayons out of a box of 24. Is this 3/4? Okay. Could also be what? 18. 18 crayons is 18. What does it have to do with 3/4? Well, because it's out of 24 that we can think of it that way, right? Here's the 0.75 that we've already talked about. That is 3/4, right, in money. I want to share 3 bottles of soda equally among 4 people. How much will each person get? 3/4. Somebody have a visual of that? That they could show a visual representation of that? Yes? No? Right? Getting only one with their hand up. I guess we'll give her opportunities to go. We're going to share 3 bottles of soda with 4 different people.
So if we're doing 3/4, the first person would get 3/4 of 1 bottle. The second person would get this 3/4, and then so this is one person, this is the second person, this is the third, right here, these 3 sections, and the last person would get the last 3.
So how much will each person get?
3/4.
3/4. Everybody see that picture? Each one of them getting 3/4 of a bottle would be 3 bottles being shared equally among 4 people. Thank you. Could this number be 3/4? Yes. How come?
Well, I saw it 2 different ways. One way is it has 3/4 more to go. So, do you see that? If you divided the thing up into 4 sections, then it's already done 1/4, there's 3/4 left. And then also, if you look between 0 and 1, it's 3/4 of the way to 1.
Okay, I see that second explanation, but I don't see your first one. What?
Okay, well, don't worry, that's fine. It's just kind of, if you flipped it, then
I think you're onto something.
it's just already covered 1/4 of the distance.
Has it? Of the distance from where to where?
From the arrow to the arrow.
Oh, so you're saying that if I took this distance right here
Yeah.
and did 1, 2, 3, there's 4 of those?
Yeah, and it's done 1, so it has 3/4 left.
That's interesting.
I looked at it just from 0 to 1, that's 1, and the dot is 3/4 of the way to the number 1.
Okay, so therefore you say it can be
Yes.
3/4,
Yeah.
which is the way you talked about the second
The
time,
second one.
right? Okay. Could this be 3/4? How could it?
If you take the green parts, even though they're on 2 squares, and just reference 1 square, those 2 green parts would equal 3/4 of 1 whole white square.
Everybody follow what she's saying? Notice she said reference 1 square. What do you mean reference 1 square?
If you looked at it as a whole, all 3 squares, that would not be 3/4 of all 3. But if you looked at just one of the 3, it would represent 3/4.
Yeah.
Okay, that makes sense, but like visually it doesn't make sense. Because that's cut down. Oh wait. Yeah. Just kidding.
So she's saying take this little piece right here and move it right over there.
Okay,
This square would be shaded how much? 3/4. Or we could move this half piece over here, right?
yeah.
So of 1 square, 3/4 is shaded. But she's saying it's not 1/4 of the entire thing. How much of that is it?
It's 1/4 of the whole thing.
It is?
Isn't it just 3?
You just show it's 1/4 of the whole.
1/4. How?
If you have 3 squares, if you divide them on 4s, 3 times 4 is 12, and then you have 3 shaded, so 3 out of 12 is 1/4.
So what you're saying is if I were to draw another line right here and do that for each one, it would be dividing each square into 4. And how many of those 4 times 3 squares would be shaded? 3 of the 12, which is 1/4. Everybody see that? Or you could say, this line is just, there's a 4th, there's another 4th, a 3rd 4th, and a 4th 4th, right? In other words, I just cut down the middle, here's a half, and then cut down the middle of the half to get a 4th and another 4th. And one of the 1, 2, 3 fourths are shaded. Can you see that one?
Yeah.
So what we're saying is the green could be 1/4. What makes the difference? Can everybody see both of those? 3/4 and 1/4? How could the same number be different? I mean, the same shading be two different numbers?
Depends on how much of the picture you're looking at.
Yes. It depends on what I reference, to use your language. It depends on what I choose for the unit. If the unit is 1 square, then the green is 3/4. If the unit is all 3 of these squares, that's my whole, then how much of the whole is shaded? 1/4. Does everybody follow that? Can you I don't know about you, but having the same shading be two different numbers right off the bat kind of causes you, but if you can see it both ways. Question?
I see the first way,
Which way?
that the shading would be 3/4 of 1 square.
Of 1 square.
But I don't understand, because if you look at the lines, like not the squares themselves, but if you were to push the squares together and look at the lines, then it is 3/4 of the whole picture.
The green is.
Yeah.
If I were to push this right over next to here and push this right over next to here,
Yeah, and look at the outside and then there's
and
4
then
squares.
and if I were to draw lines right here,
No, the
and
black lines
here.
are already there.
what lines?
Like the black lines that are going.
The big ones?
Yeah. Then there's 4 squares.
So when we push it together, there's one down the middle here, one down the middle here, and one right there, right?
Yeah, so that's 4 squares.
So it's what?
So then that has 4 parts.
Right.
One
One,
of those is
2,
colored in.
3, 4. And one of them is colored, therefore the fraction represented is
Okay, I get it.
what?
1/4.
1/4. Okay? Did you play with your hair there? You gotta watch going to an auction. You would have had the cow bought by now. Okay. Is this one? How? How could it be 3/4?
Three-fourths of one circle.
If
you reference one
circle
circle,
is my whole,
then
is my
then
unit,
then that's
then
three-fourths.
it's 3/4.
If not, it's 3/8. If you
What?
3/8, if
How?
you'd use if you were to divide both of them into 4 pieces,
If I were to
3 would be
make
colored.
another one right here,
Yeah.
if my unit is 2 circles, if that's my whole, then what's my fraction?
3/8.
3 out of 8. So the green could either be 3/4 or it could be 3/8, depending on what? What I consider to be the
You.
whole or the unit. Okay? What number is this? 3. Yeah, it's the number 3. Could it be 3/4? How? If the unit is the length from here to here, if that's the unit, then I have gone 3/4 of the length, the distance, from 0 to 4. Does that make sense? Yeah.
But then again, you don't really know if that's the entire unit because it's a line and not a line segment.
Yeah. So this could very well be the number 3, right? But could we think of it as 3/4? If, yes, you're right, we don't know. But it could be 3/4 if it's the distance that this number is from 0 to 4. It's 3/4 of the way, correct? Okay, again, depends on what your unit is. 3 1/4. Would that be 3/4? That's like 1/4 plus 1/4 plus 1/4, which is 3 times a fourth, which is 3/4. Okay. I hope out of this you got that the thing that determines the value of the fraction before you can ever even talk about the value of a fraction, you've got to what? Determine the unit. You've got to know what constitutes the whole. If you don't know what the whole is, if people don't agree on that, you'll never even agree on what the number is. Okay? So before you do anything with your fraction, you have to decide what is the whole. Then we say that whole, whatever it is, if it's 1 square, we're going to divide it into b equal parts, and we're going to consider a of those parts. That's what the fraction means. You've got to decide what the unit is. Then, so if this whole thing right here is the unit, if it is the whole, we're going to divide it into 1, 2, 3, 4 parts, right? That's the b. We're going to consider, this was shaded green, right? We're going to consider one of the 3 parts. That is the 1/4 interpretation. If our whole is this, that's our unit. Now we're going to say the green is worth 3/4 because it would fill 3/4 of one of those. Does that make sense? Okay, so for every fraction, a over b, consider first what is the whole, what's the unit, divide it into b equal parts. That's important. The best way to do, give kids a candy bar and say, okay, Johnny, give Sally half. He goes up and goes, okay, gives her that, right? Would that be half? Would you be satisfied?
Kid won't be.
The parts you divide it into must be equal or the fraction doesn't have any meaning either. Okay? All right. We've got to hurry. Get your 2-colored chips. We're going to be using 2-colored chips a number of times in here. 2-colored chips are nice because they can represent integers. When you're writing if you write out a check in your checkbook and you don't have enough money in your account to cover the check, we say your account goes into the red, right? An account that's in the red means you're in the negatives. What do we say if you're not in the negatives? You're in the black. You're in the black. Everybody familiar with those accounting terms? If your account is in the black, you're good. If you're in the red, you're in trouble. You're in the negatives. So we should have had red on one side and black on the other side, but couldn't buy them that way, so we'll go with red and yellow. What I'd like you to do is take your, with you and your partner, I would like you to make the number +5 for me. No, keep it running. +5. I want the number +5.
Well, it's gotta be this, because we're not in the red, right?
Positive means we're doing what color? Yellow. Most of you have 5 yellow chips. Does anyone have the number +5 and they don't have 5 yellow chips? Can someone do it? Do you want to come up and do it? Come up and show us how you could make the number 5 and you're not using just 5 yellow chips. Is that the number, let's get it on here so I can see it. Is that the number 5?
Yeah.
How so?
One red cancels out one hand.
This little pair right here is what? Zero. We're going to call it a neutral pair. Neutral because it's not positive and not negative as a pair, right? So guess what? I can add as many neutral pairs as I want. That's the number 5. That's the number 5, right? Okay. Make me a -3. Build me a -3.
Does that equal -2?
What's the simplest way to build a -3? With what? 3 reds. But I notice as I'm looking around, there's some of you that have something other than that, right? 3 reds with what? Any number of neutral pairs or zeros with it, right? Would also have the value of -3. Okay. All right. For this next activity, you're going to need your Cuisenaire rods. Would you please work with a partner, but record your answers on your sheet, your own sheet. In other words, you need to record your very own work, but do it with a partner.
I ordered a dress for my kid in the wedding, and then going down to the college weekend, I was going to take it to show her to make sure it's like what she wanted. And I paid an extra $12 so it would get here in 5 days. And I bought it Friday, and it's not going to be here till next Wednesday. And I'm like, you know what I'm because if it's not going to be here in 5 days, I want my $12 back.
Still running?
Yes. You know? Yeah.
Did I get it?
Yeah, we're good.
Okay. Go ahead and turn that off.